Hi, in today's video I'm going to explain how you can make more movement in your music using the modulation lanes and LFOs on the Oxi One. Effectively, a modulation lane is a way of automating a change in a parameter over time or having some manual control over that parameter. The Oxi One provides you with 4 modulation lanes per sequencer. And in addition, you have 2 LFOs per sequencer that you can route to both internal destinations, MIDI destinations, or out over CV. As always, if you have any questions or comments, leave them down below with anything you want me to explain in more detail. I love hearing from people and I try and answer everybody's question in the comments. Okay, let's get started. And in today's patch, I'm going to be using a Ranalog Morph 4 for a lot of crossfading and other VCA duties. So that's why I have the audio from Manus patched into the Morph 4, which is then going into Ikari here, Bastl Ikari as a filter. I'm using my new FX8 Pro, which I have to say I really like the screen on this, just for some delay reverb. And for fun, I've just got this Noisite, I think you pronounce it, Instruments Quasar, and this is a binaural panner which allows the sound to move in 3D around your head. So anyway, we have Manus patched in there. I can even turn up the delay. Okay, lovely. Now we can program in a very basic sequence here using sequencer 1. So I'll just clear out any notes from sequencer 1. I have this set to be a monophonic sequencer, so just 1 note per step. I'll just set the scale to be, say, Lydian, and we'll map CV1 and Gate1 outputs to be mapped onto sequencer 1, which means any notes we put in here in sequencer 1 will play. Let's use the Oxi pipe here, just for simplicity. I've got the HDMI cable here plugged into the pipe, and this white cable is just the clock out which I'm using to synchronize the delay repeats on the FX8. We can patch the pitch information into there and patch a gate from gate 1 into the trigger input. And now if we go into keyboard mode, great. We now have a working setup where we have a monophonic voice through a filter. One of the things that's nice about noise engineering modules is they are great under modulation. They really change the sound dramatically as you modulate things, and they expose a lot of that via CV. So let's experiment with using the mod lanes here on sequencer 1. Okay, I've programmed in a very simple just arpeggio here in the sequencer, which you can hear. Press the mod button and then you get access to the modulation lanes for that sequencer. So if I press mod here, the button illuminates and I have 4 controls here. Each of the knobs is used to control that particular mod lane. They're default mapped to the mod wheel, which is CC MIDI CC code 1, CC2, 3, and expression pedal, which is CC4. But you can change those mappings to whatever you want, and they can also be mapped to CV outputs as well, which is what we're going to do here. To enable a mod lane, you press the knob corresponding to it and it illuminates. So you see here I've selected and enabled the first mod lane, the second mod lane, and now no mod lanes. When you turn the knob, you change the value associated with that, which this allows you to change it live. And you notice here the pads illuminate to illustrate the value changing. So I can go all the way up to 127 and down to 0. Now, this can be recorded, this movement, so you could turn the knob like this while you're recording, or if you wanted to do some manual changes, you could do it this way. Let's patch this in and just experiment with this modulating parameters on Manus Iteratus. We're going to patch CV output 2 to the bash parameter. Let's map this first modulation lane onto CV output 2 on the Oxi One. So I press Shift and LFO to get to the CV gate menu. Now I want to go to CV output 2. It's going to correspond to sequencer 1. But what I want sent out of it is CV output 2 is going to correspond to sequencer 1 here. But instead of having pitch information, I'm going to go down to this 4th line here. And this allows me to choose a modulation source to send out of that sequencer. So for example, you can choose the 2 LFOs on the sequencer or the 4 modulation lanes. So I'm going to change that to say mod 1, and now the value of modulation lane 1 will always be sent out of the output of sequencer 1. Where it gets fun though is when I press shift on the knob and we actually get to adjust the parameters of the modulation lane. So let's take a look here. First of all, I want to draw modulation by hand. So I've just dragged my finger across the pads to draw this waveform here. I think bash is a bit noisy, so let's try it on smash. And we can change the division down to 1/8 here. But what can be fun is if I just change the ending step to step 15. Now, remember our note sequence is 16 steps, the modulation is going to be 15 steps, so now they're going to start to drift out of phase with each other. That's getting pretty crazy and pretty wild, which is just what you would expect from Sideratus when you send in lots of modulation. But one of the things you might notice is the values are very high. The range here of the output goes from 0 to 5 volts, and that might just be too much modulation. So let's go back up here in the menu, and we'll look at the mod min and mod max values. Now, I can scale this back here, the max value, say, to just say half of the range at 64, and now I'll have a much more constrained amount of voltage coming out. So that's a lot more manageable in terms of the range of modulation that I might want to use. Now, version 3 of the Oxi One firmware has added a lot more capabilities to the LFOs. Chief among them is you now have 2 LFOs per sequencer. Previously, you only had 1 LFO. Let's hit the LFO button, and this brings us into the LFO menu. Now, here you see the arpeggio notes programmed in, and the menu has changed to show LFO 1 of 2. I hit it again. I'm in LFO 2 of 2, the second LFO, and back around to where I was previously. So let's go and set up LFO 1 to modulate this parameter here on Sideratus, and LFO 2 to modulate this filter cutoff over here. So we go over to our CV gate mapping here, and I go to this and change that back to LFO 1. So that is LFO 1 of sequencer 1 going out to CV2. And here on CV output 3, I'm going to use LFO 2 from sequencer 1. So you're able to choose different sequencer and LFO combos in the CV gate mapping. You can adjust the LFO waveforms using this knob, the rate which is mapped against the number of steps. So a rate of 1/2 will repeat the period of the LFO after half of the length of one sequence. The modulation amount, which goes from 0 to 100, which controls the amplitude of the LFO, and destinations. Now, you can map the LFOs to internal destinations, which are great if you have generative sequencers and you want to change how they're behaving. Or if you press shift on the knob, you can map it to a MIDI destination. And this allows you to choose the different CC values that if you had, say, a filter or something on your synthesizer you wanted to control, that's how you would set it. But because we've gone in and mapped it automatically here in the CV gate mapping, we don't have to worry about changing that on the LFO page. Let's animate this using a triangle LFO. I'm going to set the max amount. Now you hear the sound changing. Now, I've just frozen the display here on the oscilloscope so we can actually take a look at what we're seeing. You'll notice that the bottom trace is the step trigger, so 16 steps equals 1 bar here. Remember, our LFO rate was set to 1/2. What does that mean? That means it should repeat after 8 steps. So let's put our cursors on here. Now I've set the cursors on my oscilloscope to the start and end point of the 0 point of that triangle wave, which you see with those vertical lines. And if you count the number of steps on the bottom there, the number of triggers, you'll see it corresponds to 8. So basically 8 is half of the 16 steps in the sequence, so the LFO waveform will repeat every 8 steps. We could set it to repeat, say, every bar, which is 16 steps. Let's take a look at what that looks like. Now, if I stop the oscilloscope trace, you'll see that the length of the waveform is much longer. Of course, we can make it go a whole lot faster. We can make it go per step. Let's take a look at that. That's pretty crazy, but if you did something like, for example, a sample and hold wave, that could be fun to play with. Alright, we've mapped one LFO there, and this time I popped it into Bash. It actually worked out pretty good. And we're watching that on the screen. Now let's look at LFO 2, which we press the LFO button to get to that screen. And we're going to map it to the filter here. And I wanted this to ramp down. So I'm going to choose fall, which will create a rise and fall waveform. And we're going to want it to go the length of the bar, so we'll just set it to 1 bar. We'll see what that sounds like, and we'll just set it to the maximum modulation amount, and let's see what it sounds like. Now I've set the oscilloscope up, so the pink trace 2, will show our ramp down of our LFO. Sample and hold will be the yellow trace, which will be the LFO 1, which remember we're using to modulate Bash, and the steps are the green trace on the bottom, which are the steps per sequence. Now you see how the filter is being cut off. The other thing I want to do is show you how you can use the CV gate outputs to generate envelopes. I'll just hit play on sequencer 2, which is the one I'm using to sequence pizza over here. And you'll hear those notes playing and moving across the different sounds. And if you look on the oscilloscope, I'm looking on my oscilloscope, you'll see that freezes here. Very simple Attack-Decay envelope being created. The way it works is in the CV gate output. Here we're going to map CV output 4, so we go over to 4. It's on sequencer 2. And we go down to the third output here. And so instead of outputting pitch, we're going to output trigger envelope. Trigger envelope. So CV4 output comes from sequencer 2, trigger envelope. And this lets you create envelopes. The release phase is defined by the velocity of the notes, and the attack phase is set here. And you can also set an LFO or a mod lane to modulate the attack. So I'll just set the attack to like 20. And then if I go into the sequencer and we can adjust the velocity. See, if I turn down the velocity, the notes get really short. If I turn up the velocity, they get much higher. And I could set the velocity to be different for each note. Or, for example, we could use an LFO to modulate the velocity using an internal destination. For sequencer 2, I'm going to use LFO 2 to modulate the velocity so that each note will have a slightly different velocity, which means the corresponding release phase of that envelope will be shorter each time. So the internal destination control is how I do that. And I will just turn that till it says velocity. So I've set the LFO 2 here to a sample and hold with a rate of 1/8, and an amount of 50 creates just enough variation in the velocity. Now if we watch the scope, you'll see the decay phase for each of the envelopes will vary ever so slightly. So we'll just get that little bit of movement and articulation in the sound. If I just pause the scope there, you can see on the scope that the envelopes now for each note are changing based on where that sample and hold is generating values. That shows you a good way of actually articulating your sound a little bit more using an LFO to change those envelopes. The other thing I want to do is use LFO number 1 here to create a slow ramp over 8 steps in a bar. And that's the pink trace you'll see on the oscilloscope. And I'm going to take that ramp output and I'm going to send it into the FM index here which will just modulate the FM parameter here and generate slightly different sound. And this is all configured that the sounds will move around. So you hear now that ramp is adjusting this FM index parameter.